Now begins part 3 of this lecture, where we discuss depositional environments, putting all together our knowledge of weathering and erosion, deposition, and sedimentary rock types. And at the end of this, we will also discuss soil formation. Depositional setting is a very important concept in sedimentary geology. These are the conditions in which the sediments that formed the strata, which is the rock layers that are now present, accumulated. So this picture is a great example of the various depositional environments or depositional settings that exist on Earth. I'd like you to pause the video and take 5 to 10 minutes to draw and label this graphic on a blank sheet of paper to turn in for part 1 of today's lecture activity. You may color it in. Also provide 3 to 5 sentences explaining the drawing. We will start in the mountains and go to the sea in discussion of our depositional environments. So first we discuss non-marine deposits, glacial deposits. Non-marine deposits are made in areas like lakes, streams, or on land. They are not made in oceanic or nearshore environments. One example is glacial deposits. Glaciers move large quantities of rock and sediment material as they advance in cold climatic periods. When they advance, they scour the rock surface and pick up pieces of rock which get entrained in the ice as the ice moves forward. Ice can carry any size of class, so that it's important to note that these deposits are unsorted or mixed. As the glacier recedes, it drops off these clasts in bulk. Another example of non-marine deposits are mountain streams. Streams can carry and move and deposit large amounts of material. In this picture on the bottom left, we have a stream where we can see there's lots of sandy material. If we were closer to the source of the sediment, we would likely see much larger rocks and possibly boulders, cobbles, in addition to some pieces of sand. Alluvial fan deposits are created when temporary streams deposit materials at the outlets of canyons. These occur in high relief environments or areas with lots of changes in topography or elevation. They also occur in arid or desert environments where rainfall doesn't occur often, and when it does, it often creates these alluvial fans or floods. Now we move on to marine deposits. So coastal clastic deposits are the most common sedimentary rock deposits. They're found in the ocean or in the near coastal zone called marine deposits. These form at the land and water boundary. A great example is a marine delta. For example, if you were to look on Google Earth at the Mississippi Delta, you'd see the brown river water expanding into the ocean slightly, indicating deposition of clay. Coastal carbonate deposits also exist near coastlines in warm, shallow marine environments. This is where limestone can form from carbonate reefs or from plankton that die and settle on the ocean floor. Florida is a combination of both clastic and carbonate deposits in succession over time. At deep marine locations, most sediments are extremely fine clays or skeletal remains of planktons. This is because all other material is too dense to be carried deep into the ocean. All other sediments were dropped off much closer to land and their source. These deep marine deposits of fine materials produce finely laminated mudstones, cherts, or chalks, which is a type of limestone. On the right, we have some diatoms a photomicrograph of some diatoms, which would produce a chert because they're made of silica. Sedimentary basins are the areas where sediment gets deposited. There are several types. There are foreland basins on the edges of mountain belts, rift basins where continents are starting to rift, producing narrow troughs, intercontinental basins in the interior of the continents, possibly over old or failed rifts, and then the largest of them and the most preserved are the passive margin basins, and these form on the edge of continents at thin crust at the intersection with oceans. It's important to note that these are on passive margins, not active margins. So the edge of the east coast of the United States is a passive margin basin, so there's lots of sediment being deposited on that coast, whereas on the west coast of the United States we have an active margin. There is subduction going on, volcanism, and mountain building activity, and not that much sediment is being deposited in the Pacific Ocean in this area. An important concept for sedimentology, or the study of sediments and sedimentary rocks, is these concepts called transgression and regression. As sea level changes, deposits of sediment show evidence of these changes. So, and in one particular location, if the shoreline was to move inward, this would be an example of sea level rising, and this would be called a transgression. As the sea level moves seaward, or sea level falls, this is a regression. And transgressions and regressions are seen in the sedimentary rock record as we move from fine-grained materials like clays to coarser-grained materials like sands. The textbook provides a nice video of transgression and regression that I will provide a link to and hope that you watch. Last, we will briefly discuss soil and its formation. There's three key processes involved to create soil. First is weathering of bedrock, second is infiltration by water, and third is biological activity. Each of these three processes are important in creating a soil, which over time results in different horizons at different depths, indicating different processes occurring. One example is that in a temperate forest soil, you may have an organic horizon, an A horizon, which is the topsoil, an E horizon, which is a transitionary location, B, which is subsoil, and the C horizon, finally, which is the weathered bedrock. On the right, you can see a picture of these different horizons in a schematic and in real life. Now we'll talk soil classification. So different soil types exist in different environments. These depend on local climate, the composition of the soil and the local bedrock, the steepness of the slope, the vegetation type that's present, among other factors. So the desert soil on the left is high in calcite, which accumulates to form caliche. A temperate soil, which was discussed in the previous slide, has a variety of horizons, including an organic layer of humus. On the right, we have a tropical soil, or an oxysoil, where percolating rainwater leaches all soluble minerals and leaves only iron and aluminum-rich residues. Your textbook also has a nice video on forming soil that you should watch.